Ladies and gentlemen, may I direct your attention to the center, page of the notebook. We are going to try the arrow method versus the half reaction method, basically side by side. Same reaction. We're going to do this basic solution. You tell me which you like. We're going to go through each in their own individual steps, see how the same answer turns out, and then we'll see which one we like better. It's up to you. Okay, let's do oxidation number or arrow method first. Oxidation numbers, -2, total of +4, -1, -2 for that, because oxygen in a compound, hydrogen in a compound. This is Mn by itself, Br by itself, a +1 for the hydrogen and a -2 for the oxygen. That's why hydroxide is a -1. Great. Okay, arrows between things changing oxidation number. Clearly the Mn's are changing and the Brs are changing. Good. Balance atoms with arrows attached. There's 1 Mn per every 1 Mn, and there's 2 bromines per every 1, or 2 bromides per every 1 bromine. Oxygens go from -2 to -2 and +1 to +1, so that's not part of it, and we don't look at charges on ions of compounds, only on individual monatomic ions. Okay, so we balanced atoms with arrows attached. Now let's do the electron exchange. 1 Mn times +4 is a +4 for the Mn and a 0 for this. So from +4 to 0, we are getting negative by 4. 2 times -1 is equal to -2. 2 times 0 is equal to 0. To get from -2 to 0, getting more positive, so we're losing 2 electrons. +4, -2, this has to be multiplied by 2, this has to be multiplied by 1. The 1 jumps down here, and that coefficient is 1 times 1. 2 jumps up here, coefficient is 2 times 2. Now we're rewriting, showing these 2 coefficients and ion charges on monatomic ions. We don't know but we're leaving off straight oxidation numbers. Okay, so the Br is a -1 charge. That has a 0 overall charge. That is a 0 overall charge. But the Br has to show its charge. We don't know what that is yet. We don't know what that is yet. And we don't know what that is yet, but we know it has a -1 charge. Okay? Good. Now let's balance by inspection. 1 Mn per every 1 Mn, 4 bromines, 2 bromines for this diatomic molecule ends up with 4 total bromines on each side. Good. Now what? We add hydroxides to both sides to get the charge. So what's the total charge here? We got 1 times 0 plus 4 times -1 plus, times 0. Well, that all adds up to -4 on the left. And that's set in stone, because no matter what this coefficient is, it's going to stay -4. Which means we have to end up with a total of -4 on the right. So how do we get -4? Well, that's 1 times 0, and this is 2 times 0. So it's something times -1 has to be equal to -4. It's got to be a 4, right? So we need 4 hydroxides. Good. Now that we have all these coefficients, it's easy to tell that we have 4 oxygens on the left. And so we need to have 4 oxygens on the right. With me? Well, how do you get 4 oxygens on the right here? You got 2 oxygens from this, none from here. So you need 2 oxygens from the waters, right? That means 2. And if there's 2 waters, that's a total of 4 hydrogens. Checks out with 4 hydrogens. And we're done. That's the balanced equation. Okay, it looks like that took right around 5 minutes or so with a full explanation of everything. Alright, let's check out this one. Now let's do it the half reaction method. Okay. MnO2 going to Mn is the 1/2 reaction. Br minus 1 going to Br2 is the other half reaction. Alright, let's balance the atoms and then add 2 waters and then add 4 H pluses, and now we've got to balance the electrons, right? Balance the charge using electrons. This is 0. This is plus 4. So we're going to add 4 electrons on this side to get everything to balance out. Good. But we're not done because we don't have any H pluses in this solution. We only have hydroxide ions. So what do we have to do? We have to neutralize by adding 4 OHs on this side, but if we add O's and H's and minus 1 on this side, we have to add 4 OH minuses on this side so that we're still balanced, right? You can't just add them on that side. Well, what does that add up to? That adds up to 4 H2Os. So let's rewrite this. We've got 4 H2Os plus 1 MnO2 plus 4 electrons goes to 1 Mn plus 2 H2Os plus 4 OH minus 1s. Okay, that's not 40 H minus 1s, that's 4 hydroxides. Okay, well if we've got 2 waters on this side and 4 waters on this side, these all go away. That's 2. So our final balanced half reaction here is 2 waters plus 1 MnO2 plus 4 electrons goes to 1 Mn plus 4 hydroxides. 4 hydroxides. Okay, that's that half reaction right there. Now we got to balance this half reaction. 2 bromines, bromides per every 1 bromine. There's no oxygens that we have to add on either side, so that makes that easy. No waters, no nothing. So we're going to add 2 electrons on the right-hand side to get everything to balance. Again, we don't have to neutralize any acid or anything like that. No H pluses. So we're done here. That's the half reaction. Alright, so if we've got 4 electrons, we have to multiply here by 2 and here by 1, right? So that means we've got 2 H2Os plus 1 MnO2 plus 4 electrons goes to 1 Mn plus 4 hydroxides. And then here, on this side, there's 4 Br minus 1s, 2 Br2s, and 4 electrons. The electrons cancel. Nothing else cancels. So we've got 2 waters plus 1 MnO2 plus 4 Br minus 1s goes to 2 Br2s plus 1 Mn plus 4 hydroxides. Done. Almost identical amount of time. Exact same answers. It's up to you. Whatever you like best. I'm telling you, for me, this hydroxide, balancing out, neutralizing acid, gets a little complicated. I like the arrow method. It's up to you. I just want you to get them right. Whatever it takes. Okay, practice up. Good luck.